Welcome to the new tutorial on how to use Avida ED's new web browser. This program now runs in a web browser, so is platform independent. First, navigate to the appropriate URL. This program works best at the moment in either Chrome or in Firefox, but is usable from several different browsers. You'll notice here that the panel that is displayed before you is subdivided into several different sections. Up here in the upper left, we have the navigation section. Underneath it, we have the freezer. In the center of the workspace is the lab bench, currently showing the virtual petri dish. Over on the right-hand side are information panels, both about selected organisms and about the entire population. Let's start out looking at the ancestral organism. First, come over here to the organism viewer and click on the button that says organism. From here, you can drag an organism, in this case we are working with the ancestor, into the workbench. Organisms within Avida ED are strings of self-replicating computer programs. If we are to click Run, we can see what happens when this organism executes all of its instructions. Goes through copying one instruction at a time. You'll notice that not all of the organism's instructions are copied perfectly, but some have become different in the offspring than they were in the parent. These are highlighted in green with dark circles around the edges and represent new mutations which have arisen. When studying organisms in the organism viewer, by clicking on the Settings button, you can choose what that mutation rate is going to be during analysis, either by dragging the slider up or down, or clicking in here and typing a new percentage. Click anywhere else to lock that in, and then click either the X button to cancel or the Done button at the bottom. This will have set the new mutation rate. If we click here again, you'll see that we now have a much higher mutation rate, and we can expect to see more mutations in the offspring organism. This can be stopped at any moment. It can also be run forward one step at a time, or backwards one step at a time, to determine exactly what is happening. Up here, there will be a display on whether the organism has performed any of the different logical tasks for which it is rewarded. And here, a graphical display of all of the underlying computer architecture with the ability to look at additional details of individual instructions, should you be so interested. This will continue running until the organism has completed a copy. We can see here that by changing our mutation rate, we have drastically increased the number of mutations that have occurred within the offspring organism. Now, come back here to the population view. This is initially showing the virtual petri dish. Each one of these squares represents space for a single organism. By clicking on Setup, we can change various features of this world. We can choose to change the world size, which starts out as 60 by 60, to something a little smaller so it will be filled faster. We can change the mutation rate, again by moving the slider forward or backwards, or by clicking in the box, typing a new number, and hitting Enter. We can choose to place the ancestral organism here into this box, which will guarantee that it goes into the middle of the petri dish. We can control whether offspring are born near their parent or randomly throughout the world. We can control whether any particular resources are available for them, ranging from easy tasks all the way through brutal tasks, which correspondingly give larger rewards to individuals who complete them. We should keep things at the experimental repeatability mode so that new random numbers are generated all the time, although it may be in your interest at times to run things in the demo mode, where there is a set string of random number inputs. You can pause the run manually, or choose to have it pause at a particular update. With these settings, we can go back to the map and start a run by clicking the Run button. You'll notice that at first, organisms only exist within the middle of the world because we have organisms being born near their parents. Relatively rapidly, the world will fill up. Each one of these squares represents a different one of the organisms living within the world, and they are colored according to their fitness. These colors will rescale as fitness of individuals in the population increases over time. By clicking on any one individual box, we can get information about the organism that is living in that particular location. That will be displayed here under the Selected Organism Type information view. Further, we can get information about the entire population by looking here at the population statistics. You can see at the moment, no organisms have performed any of the different logical tasks because our ancestral organism was only capable of replicating itself. However, due to random mutations, eventually an organism will be born capable of performing one of these simple logical tasks. Because those tasks are rewarded, there will be a fitness benefit for those individuals, which will then tend to replicate faster than others. These individuals will then spread through the population. If we wish to find the organisms which are performing these particular tasks, we can click on the button corresponding to the task, and each organism that is performing it will be highlighted with a green box around the edge of it. We can also look for organisms performing combinations of tasks. But at the moment, none of our organisms are doing more than just one task. We can pause the run at any point we wish, and we can choose an organism to save to the freezer. So let's choose here one of these organisms performing this more complicated task. Click on the organism and drag it over to the freezer. This will prompt us to name our organism. Click OK, and that organism will now be present within the freezer. We can then come back over here and click Run again to continue the run at any time. We can also choose, if we wish, to freeze the entire dish by clicking the Freeze button at the bottom of this pane. This gives us the options to save the configurations, the organism, or the population. Clicking here for population, we can say that this is our initial run. Click OK, and that will show up here in the populated dishes. We can start a new run by clicking the New button. This will ask us whether to save the dish or not, or if we wish to discard it. Going back here to the setup and again reducing the world size to make things a little bit easier to see, we can then come back here to the map and drag different organisms into different locations. If we wish to compete our evolved population, our evolved organism rather, versus the ancestral organism, we can drag them both into the population. Then, by clicking on Mode, instead of coloring things by fitness, we can color them by which organism gave rise to them. If we start the run, we can see that these two organisms reproduce at radically different rates. This one, which is performing a complicated logical task, runs much faster than this one, our ancestor, which is not performing any of the tasks. Just as before, we can freeze this population to look at it later. We refer to this as the competition. In addition to simply being able to look at these organisms this way, we can choose to export the data by coming up here to File and choosing Export Data. You will now see that a data file has appeared in the bottom. We can click on this and open the data file. You are now ready to begin running your experiments with Avida ED.